Objects don't truly exist. I know how ridiculous that sounds at first. Right now, you're looking at your phone or your computer. It's right in front of you. You can see it, touch it, interact with it. How could anyone seriously claim it doesn't exist? But stay with me. After decades immersed in quantum mechanics, quantum field theory, and the holographic principle, I've come to understand that objects, as we instinctively imagine them, are not fundamental elements of reality. They're practical stories we tell ourselves, emergent patterns, mental frameworks our brains use to organize information. At the deepest layer of physics, objects simply aren't there. Something else is. Let me take you on a journey through modern physics, and I'll show you why objects are illusions and what truly exists beneath them. When I was younger, long before I became a physicist, I never questioned the reality of objects. A chair was just a chair. An apple was an apple. A person was a person. These were distinct, separate things with clear boundaries, stable identities, and properties that endured over time. This is how we function in everyday life. We treat objects as the basic units of existence. Our language is built around them. Nouns point to objects. Our entire cognitive framework assumes that objects are real, but physics tells a very different story. So let's begin with the most basic question. What is an object? Intuitively, an object is something with boundaries, something separate from other things, something that maintains its identity through time. This chair is not that table. This is one object, that is another. But where exactly is the boundary? A chair is made of atoms. Those atoms are held together by electromagnetic forces, yet those forces extend infinitely in principle. The electric field produced by an electron in this chair stretches across the universe, weakening with distance, but never truly dropping to zero. So where does the chair end and the surrounding air begin? There is no sharp dividing line. There's only a gradual shift from a high concentration of chair atoms to a lower concentration of air molecules. The boundary is fuzzy, arbitrary, defined by convenience rather than nature. You might say, fine, boundaries are blurry, but the chair is still the collection of atoms that compose it. Those atoms define the object. But which atoms? Atoms are constantly being exchanged with the environment. You inhale air molecules, and they become part of your body. You exhale, and they leave. Are you the same object after breathing? What about after eating? When atoms from food are incorporated into your cells, your physical makeup changes. Over roughly 7 years, almost every atom in your body is replaced. If objects are defined by their constituent atoms, then you are a completely different object now than you were 7 years ago. And yet, you feel like the same person. So identity cannot be tied to specific atoms. It must instead be tied to patterns, structures, organizations, arrangements. And that gets us closer to the truth. Objects are patterns, not things. They are organized structures, not fundamental entities. But let's go deeper. Those atoms themselves, what are they really? We once believed atoms were indivisible, fundamental objects. That's what the word atom originally meant. But then we discovered that atoms are composed of electrons, protons, and neutrons. So maybe those are the true objects. Then we learned that protons and neutrons are made of quarks. Are quarks the fundamental objects? In quantum field theory, even quarks are not objects in the classical sense. They are excitations of quantum fields. A quark is not a tiny solid particle. It's a localized disturbance in a field, a ripple, not a little bead of matter. And what is a field? A field is a mathematical structure, a function assigning values to every point in space-time. The electron field exists everywhere, at every point in space. When that field is excited in a particular way, we interpret that excitation as an electron. The field is fundamental. The particle is a convenient description of a localized excitation. So electrons are not objects. They are field excitations. And fields themselves are not objects either. They are mathematical entities, patterns of values spread across space-time. Objects dissolve into mathematics. Let me make this clearer with light. We often say light is made of photons, particles of light, but photons are excitations of the electromagnetic field, a field that permeates all of space. When this field is excited in a certain configuration, we call it a photon. But where is the photon? It's not located at a single point. It's spread out as a wave across space. The configuration corresponding to a photon occupies a region, not a precise location. The photon doesn't have a definite position until it's measured, and even then, measurement fundamentally alters the situation. Before measurement, the photon exists as a wave function, a quantum superposition of many possible positions. After measurement, you find it in one place. But did it exist there before you measured it? Quantum mechanics says no. The photon is not an object with definite properties independent of observation. It is a quantum field excitation that only appears particle-like when observed. Objects don't truly exist. What exists are field configurations, patterns of excitation. Discrete, localized objects with fixed properties are approximations, classical descriptions that emerge from deeper quantum realities. Now let me tell you about something that really drove this point home for me: quantum entanglement. When two particles are entangled, they are not separate objects. They form a single quantum system that cannot be divided into independent parts. If I have two entangled electrons, I cannot describe one without referencing the other. The quantum state belongs to the pair as a whole, not to the individuals. Asking for the state of just one electron makes no sense. There is no separate state. This is profound. It means the electrons are not independent objects. They are components of a larger, indivisible whole. The appearance of two separate electrons is an illusion born from classical intuition. Quantum mechanics forces us to abandon the idea of objects as independent entities. Everything is connected, entangled, part of a larger quantum whole, and it gets even more unsettling, or fascinating, depending on how you look at it. In quantum field theory, the vacuum, empty space, is not empty. It's teeming with quantum fluctuations. Virtual particles constantly appear and disappear. Electron-positron pairs pop in and out of existence. Photons flicker into being and vanish. The vacuum is a restless sea of activity. Are these virtual particles objects? They exist too briefly to be directly observed. They borrow energy from the uncertainty principle and repay it almost instantly. They're not real in the classical sense, yet they have measurable effects. They shift atomic energy levels. They contribute to forces between particles. The line between existence and non-existence becomes blurred. Objects flicker in and out of reality. The distinction between something and nothing loses its sharpness. Empty space isn't empty, and particles aren't permanent. Everything is in flux all the way down. All. Now let me connect this to the holographic principle, something I've spent much of my career studying. It completely transformed how I think about objects. The holographic principle states that everything contained within a three-dimensional volume of space can be encoded on a two-dimensional boundary. All the information, all the degrees of freedom, everything that exists inside the volume is represented on the surface. In black holes, this idea is concrete. A black hole's entropy, its number of possible quantum states, is proportional to the area of its event horizon, not its volume. The interior contains no independent information. It's redundantly encoded on the surface. If this is true for black holes, it likely applies universally. The holographic principle suggests that our three-dimensional universe is a projection from two-dimensional information. What does this mean for objects? It means objects in three-dimensional space are not fundamental. They are holographic projections of lower-dimensional information. The chair you're sitting on is not truly a three-dimensional object. It's a pattern in two-dimensional information that your brain interprets as three-dimensional. Objects don't exist in three-dimensional space because three-dimensional space itself is emergent. It's an illusion produced by holography. This isn't speculation. The AD-CFT correspondence, discovered by Juan Maldacena, demonstrates this mathematically for certain spacetimes. A three-dimensional universe with gravity is exactly equivalent to a two-dimensional quantum field theory without gravity. Objects in the three-dimensional bulk, black holes, stars, planets, are not fundamental. They emerge from the boundary theory. They are holographic projections. Objects don't exist as true three-dimensional entities. They are shadows cast by two-dimensional information. Now let's consider another reason objects don't exist: the measurement problem in quantum mechanics. Before measurement, a quantum system exists in a superposition of states. An electron can be in multiple locations at once. Schrödinger's cat can be both alive and dead. Does the object, the electron, or the cat exist in a definite state before measurement? According to the Copenhagen interpretation, no. Definite properties come into being only upon measurement. But what counts as a measurement? Does it require consciousness? Can a machine measure? Can an atom? The measurement problem arises here. I believe decoherence offers the resolution. When a quantum system interacts with its environment, an environment with many degrees of freedom, the branches of the superposition effectively separate. From within any one branch, it appears that the object has definite properties. But fundamentally, all branches still exist. The electron remains in superposition. The cat remains both alive and dead. Definite objects exist only relative to observers in particular branches. Objects with fixed properties are observer-dependent. There is no objective, observer-independent object with intrinsic properties. Objects exist as quantum superpositions, and classical definiteness emerges only in relation to observers. Consider the ancient puzzle of the ship of Theseus. Over time, every plank and nail of a ship is replaced. Eventually, none of the original parts remain. Is it still the same ship? Now imagine taking all the original parts and rebuilding a ship. Which one is the original? The puzzle shows that object identity is not well defined. There is no objective answer. Identity is a matter of convention. Physics deepens this problem. At the quantum level, particles are indistinguishable. All electrons are identical. Swapping two electrons changes nothing physically. There is no fact of the matter about which electron is which. After interaction, you cannot say which electron came from where. Identity doesn't exist for fundamental particles. Macroscopic objects inherit this ambiguity. If the electrons in my body are indistinguishable from all others, in what sense am I a distinct object with a persistent identity? I am a pattern of indistinguishable particles in constant exchange with the environment. Identity is a useful fiction, not a fundamental feature of reality. Now let's bring in relativity. In special relativity, simultaneity is relative. Events that are simultaneous in one frame are not simultaneous in another. That means the idea of an object existing right now is frame-dependent. In your frame, all parts of a chair exist at the same moment. In another frame, different parts exist at different times. There is no objective set of parts that define the object at an instant. In general relativity, this becomes even more extreme. Space-time is curved, and there is no unique way to slice it into moments. Different observers disagree about what exists now. Objects persisting through time have no frame-independent definition. They are observer-dependent constructs. Black holes crystallize this insight for me. From an external observer's perspective, an object falling into a black hole never crosses the horizon. Time dilation stretches infinitely. The object appears frozen at the horizon, its information smeared across the surface. From the infalling object's perspective, it crosses the horizon smoothly and continues inward. Which is correct? Black hole complementarity says both descriptions are valid, but mutually exclusive. The object has no frame-independent existence. It exists on the horizon in one description and inside in another. Objects are description-dependent patterns, not absolute entities. You might think all this only applies to extreme situations, but everyday objects are made of quantum stuff. Chairs are composed of atoms, which are quantum field excitations. Their solidity and stability are emergent features. The chair is not a static thing, it's a dynamic process. Its atoms vibrate, exchange energy, and entangle with the environment. You cannot describe the chair independently of the air, the floor, the photons interacting with it. The chair is not a separate system, it is part of a larger quantum whole. Boundaries are arbitrary, drawn by convention, not by nature. Objects are also scale-dependent. At human scales, we see chairs and tables. Zoom in and you see molecules, then atoms, then quantum clouds. Zoom out and objects merge into larger systems. The Earth Moon system, the solar system. There is no privileged scale where objects are truly fundamental. At every scale, objects dissolve into components or merge into wholes. The deepest reason objects don't exist is that locality itself is emergent. We think objects are localized in space. But if space is emergent, as holography suggests, then locality is emergent too. In the boundary theory of ADS-CFT, there is no bulk space, only a lower dimensional quantum field theory. Objects localized in three-dimensional space do not exist fundamentally. They emerge from patterns in non-spatial information. Objects are illusions of locality. Even in quantum mechanics, particles are better thought of as histories rather than things. In the world-line formulation, particles are curves through space-time. In the path integral formulation, particles take all possible paths simultaneously. The classical picture of a particle following a single trajectory is an approximation. Objects don't exist as things moving along definite paths. They are superpositions of possibilities. So what are you interacting with when you pick up a cup? You're interacting with a stable pattern of quantum field excitations. The pattern is real. The interaction is real. But the object is not fundamental. It's like a wave in the ocean. The wave appears to move, but the water molecules merely oscillate. The wave is a pattern, not a thing. Objects are like waves, real as patterns, not as fundamental entities. This perspective resolves many philosophical puzzles. Objects don't persist, patterns do, composition problems dissolve, measurement becomes less mysterious, black hole paradoxes find resolution. Even personal identity shifts. You don't exist as a fixed object, you exist as a process, a dynamic pattern. Your consciousness is not a thing, it's an evolving activity. You are more like a wave than a rock. This resonates with the Buddhist concept of anatta, or non-self. The self is not a permanent essence, but a temporary pattern. Physics echoes this insight. There are no permanent objects. Everything is process pattern flux. In curved spacetime, even particles become observer-dependent. What looks like vacuum to one observer appears as a thermal bath to another. Objects are not objective features of reality. They depend on perspective. When you put it all together, objects dissolve at every level. They dissolve into fields, superpositions, information, frames, observers. There are no objects, only quantum states, information patterns, processes. Objects are useful fictions, emergent approximations, ways of organizing experience. Reality is richer, more interconnected, more subtle. The universe is not made of objects. It is made of quantum information arranged into patterns we interpret as objects. Objects are the map, not the territory. They are beautiful, indispensable illusions, and seeing through them is one of the great achievements of modern physics.